Hi everyone. So today we're going to look at how to add and subtract rational expressions with like denominators. Okay, so let's begin. On this first problem, we have two rational expressions with the same denominators, with like denominators. Well, if we're adding rational expressions with like denominators, it's basically like adding fractions with like denominators. So we know that, clear the board here. Well, we know, let me just put this on the bottom. We know that if you have an expression, let's say 3/5 plus 1/5, okay? In order for us to add these fractions, we need to have common denominators. In this case, we do. So all we do now is to just add the numerators, right? So it's 3 plus 1 over 5, which is 4/5, correct? So adding rational expressions is the same idea as just adding two fractions. All right, but again, they must have like denominators. So let's go back to the problem, and we have this, right? We have 8k squared plus 4 over 5k squared plus 5 plus k cubed minus k plus 8. All right, so what I'm going to do here is, let's see if I can actually do it on this page. I think I can. So everything is going to, these are the same denominators. So let's just add the numerators. We're going to add 8k squared plus 4 plus k cubed minus k plus 8. Okay, all over 5k squared plus 5. Okay, so basically I'm just going to write it on this side. So first step, we need to get common denominators, right? Common denominators. Right? So I'm just going to write it like that. I'm going to get common denominators. And then second, once you do that, you're going to just add or subtract, right? Or subtract the numerators. Okay? I'm just going to just go like that, all right? And then finally, once you've done that, then what we can do is to, if we can factor and cancel, this is the step to do so. Okay, so our final expression, if we can factor and cancel, okay, this is the step to do it, and then finally to write our simplified form. So, okay, so you're going to simplify. Okay, so basically these are the 4 steps that we're going to use when we're adding and subtracting rational expressions. These already started with common denominators, so we're good. Now we are in the process of adding our numerators, right? Numerator. So let's add it up, combine like terms, right? So we combine like terms. So we're going to have k cubed plus 8k squared, and then minus k plus 12, right? Like that. All over 5k squared plus 5. Okay? So let's see if this is going to be our final answer. All right? Let's take a look. Again, there's a lot of typing here, correct? K cubed. You know what? I'm going to start with the fraction bar. So it's going to be k cubed plus 8k squared minus k plus 12 that going to present a problem? Minus k plus 12 over, yeah, it's going to present a problem. Okay, so let's just redo that all over again. So k cubed plus 8k squared minus k plus 12. Okay, all over 5k squared plus 5. Okay, and that is correct. Okay, a lot of typing, right guys? Okay, so again, get common denominators, then add or subtract the numerators, combining like terms, right? Factor, cancel, and simplify. In this case, we didn't factor and cancel anything. We just left it, and then we just type that in as our final answer. Okay, let's go here and take a look. So in this problem, again, this is a subtraction problem, right? So just like when we're subtracting fractions, and I'm going to just do it right over here, right? Actually, I'm going to go over here and do it. Remember, when now we're subtracting, let's say 3/5 minus 1/5, we know that we can rewrite this as 3/5 plus negative 1/5, right? It's the same thing. Correct, guys? And that's going to, once we convert that into an addition, then we can just add the numerators again. So it's 3 minus 1, 3 plus negative 1, which is 2/5, correct? So we can do, remember, this is just keep, change, right? To change from a subtraction to an addition, right? To go from a subtraction to an addition, we use keep, change. So we're going to apply the same idea here. We're going to make this subtraction into an addition, and then we're going to work on it, all right? So let's do it. We're going to have 9x squared plus 3 over 14x squared minus 9. And now comes the, we're going to keep this, right? Keep this. And then we're going to change subtraction to an addition. So here's your change. And then we're going to change this numerator, just the numerator, right? So we're going to change the signs in the numerator. So the negative 3x squared becomes positive. So just 3x squared. All right? And then, remember, we have to now think of it as a distributor problem, right? So it's negative is positive, and negative is negative. So minus 5 all over 14x squared minus 9. Okay? So if you wanted to, I mean, I could have, maybe I'll do it on the side here. This would have been negative 3x squared plus 5, right? And if you distribute that, you'll get this. All right, now we are ready. Now we are ready to combine like terms, add up the numerator, right? That was the change. So we're going to have 9x squared plus 3x to 3. Oh, so we can, let's combine these then, all right? So let us combine. We're going to get 9x squared plus 3x squared is 12x squared. And then we're going to have plus 3 minus 5 is minus 2. And that's going to be all over 14x squared minus 9. Okay, so let's type that in and see if that's our final answer. Go up here, again the division symbol first, 12x squared minus 2 all over 14x squared minus 9. Okay, and hopefully that is correct. All right, guys? Okay, good. Okay, so maybe we can finish this up if we're lucky. So let's go on to our next problem here. Again, denominator is the same. It's an addition, so let's add up the numerators. So we're going to have z squared plus 4z squared is 5z squared, and then minus 6z. Okay, all over z cubed plus 4. This was a pretty straightforward one, right? So luckily, I think that's all we need to do here. So 5z squared minus 6z all over z cubed, z cubed plus 4. And that is correct. Okay, last problem. This is subtraction. So again, we always want to change a subtraction to an addition. And if you look here in this first term, you see that this is backwards, correct? So I'm going to write that in standard form as well. So again, okay, remember your steps. First step is to get common denominators, right? Get common denominators. So get common denominators. That is a check. They are common denominators. And I would rewrite everything, again, I would rewrite everything into standard form. So maybe put that as step 0. Okay? Okay, put everything in standard form. Standard form. Okay, and then 2. Okay, now you can add the numerators, right? Add or subtract the numerators. Okay, numerators. And then, of course, 3 is you can factor and cancel. But in this case, we're not doing this. But in the later problems, we will have to do this. Oops, sorry. Factor and cancel. So factor and cancel. And then simplify. Okay? So simplify. Right to. So let's get right to it. Okay, rewrite everything in standard form. So I'm going to go negative 6k cubed plus 4 over k cubed plus 3. Okay, now I'm going to change the subtraction to an addition, plus, and then I'm going to change the numerator, all the signs in the numerator. So it's 2k squared minus 7. And then rewrite the bottom again in standard form. K cubed plus 3. And now let's add the numerator, right? We got the same denominator, so let's add the numerator. We're going to have negative 6k cubed plus 2k squared, and then 4 minus 7 is minus 3, all over k cubed plus 3. Okay, so let's type this in. We're going to have, again, the division sign in first, negative 6k cubed plus 2k squared minus 3 all over k cubed plus 3. And if we did everything correctly, it should be all right. And that is correct. Okay, guys? All right.